Okay, in this next video we're going to talk about the factor theorem. The factor theorem gives us a condition for knowing when a particular polynomial is a factor of a given polynomial. So we begin with letting f of x be a polynomial. We say that x minus c is a factor of f of x if and only if f of c equals 0. Okay. Well, this may seem kind of straightforward, and it really is, but we do want to take some time to prove this. This is an if and only if proof, so that means we got to go both ways. So we'd have to start by showing that if x minus c is a factor, then f of c must be 0. So we begin with that. Well, if x minus c is a factor, then that means that x minus c divides evenly into f of x. If x minus c divides evenly into f of x, then that means that when we divide by x minus c, we don't have a remainder. But then by the remainder theorem, the remainder is equal to f of c, and so f of c must be 0. And so there it is the first way. Going the other way now, we begin with the assumption that f of c is 0. Oops, sorry about that. Hit the wrong button and got everything. So if f of c is 0, then the remainder is 0. But if the remainder is 0, then that means that x minus c divides evenly into the polynomial, and so therefore x minus c is a factor. Okay, so that's the factor theorem. So now, as an example, to show you where this factor theorem is useful, basically what the factor theorem says is if we can evaluate the function and get 0, then we know that x minus whatever that value was is a factor. So consider our x to the fourth minus 3x squared minus 4. And here's how the factor theorem is useful. Let's say we know f of 2 is equal to 0. You can do that by plugging 2 into the function. And so because f of 2 is 0, we know that x minus 2 is a factor. Currently we're dealing with a fourth degree polynomial. Most fourth degree polynomials cannot be factored very easily or solved by factoring. So knowing that x minus 2 is a factor, we can now use synthetic division to divide it out. And so we do that. Remember, in synthetic division we bring down the 1. 2 and 1 would be 2. 0 and 2 is 2. 2 times 2 is 4. Negative 3 plus 4 is 1. 2 and 1 is 2. 0 and 2 is 2. 2 and 2 is 4. Negative 4 cancels out, and we've kind of confirmed what we already knew. So now we can actually write that as the polynomial x cubed plus 2x squared plus x plus 2. Now, having it as a third degree polynomial, maybe we can do something with it, maybe we can't. But we know something else as well. We actually found this out earlier in a separate video, that f of negative 2 is also 0. So I can take my negative 2 and divide that into the remaining polynomial, writing down its coefficients. And so we again go through the process of synthetic division. Bring down the 1. Negative 2 and 1 is negative 2 would be a 0. Negative 2 and 0 is 0. 1 and 0 is 1. Negative 2 and 1 is negative 2. Negative 2 and 2 is 0. And so now what we've done is we reduced the problem from a fourth degree polynomial down to a second degree polynomial. Now this second degree polynomial actually doesn't have any real roots, real solutions. You may recall that it has two solutions, positive I and negative I. So the main use of the factor theorem is we can evaluate the function to find a 0 value, use synthetic division then to divide out that factor to reduce the degree of the polynomial. Hopefully down to a second degree polynomial, which we can deal with using some of our methods or the quadratic formula. So that's the factor theorem.